Let's do the N2o Lewis structure. N2o has 16 total valence electrons. There's 3 ways we can draw it, and all of them work pretty well. Let's take a look. For each structure, the atoms have fulfilled their octets, and for each Lewis structure, all the 16 valence electrons have been used. So we need to decide which one of these is going to be the best structure. And to do so, we're going to have to look at formal charges. Let's start with this one right here. For this first nitrogen right here, on the periodic table, nitrogen has 5 valence electrons. Non-bonding, these, 4, and then bonding, we have 2 bonds here, so that's 4 valence electrons we divided by 2. So the total formal charge for this nitrogen right here, it's going to be -1. For the nitrogen in the center, we have 5 valence electrons. All of the valence electrons are bonding, so that's 0. And we have a total of 2, 4, 6, 8. 8 bonding valence electrons divided by 2. 5 minus 4 is +1. So we have a formal charge of +1 on this nitrogen right here. The formal charge on the oxygen turns out to be 0. We can calculate the formal charges on the other Lewis structures for N2o the same way. We want to choose the Lewis structure that has the formal charges closest to 0. So when we look at this up here, this -2 plus 1, this one's out, so we're not going to look at this one. We're left with these 2 here, which look pretty much the same. We have a +1 and a -1, and a +1 and a -1 here. What we want to do is choose the Lewis structure that has the formal charge, the negative formal charge, on the most electronegative element. Oxygen is more electronegative than nitrogen, so we don't want to choose this one here. And here we have that negative charge on oxygen, which is more electronegative. That's going to make this the best Lewis structure. This is Dr. B, and thanks for watching.